So, our next speakers, Jean-Marie and Arun, are going to talk about Scotch tape and Flashrom and the way of the UEFI, and enjoy the talk. Big round of applause, please.
So, good afternoon, everybody. As you can hear, I'm French. So how many French people in the room? So at least 2 people might be able to understand me. So sorry for the accent. I'm working for a company called IT Renew, and I was leading Horizon Computing, but we have been acquired back in June. Our job is to design open hardware servers, and we are reselling recertified hardware and new hardware. We are trying to expand the life cycles of the machines. And we are deeply involved into the Linux boot projects because we want to get rid of the AMI system BIOS, which are aging on these machines. So that talk is not about who I am, but it's more about that I'm sharing with Arun since a couple of months. So we met, I think, in 6 months ago or 3 months ago, just before summer. So we are back to school, so it was in March, more 6 months ago. And Arun is new to system BIOS development and discovered the joy of running testing with low-level firmware development. And the story about the Scotch tape is more what kind of hint we could provide to Arun on how to upgrade the firmware on a Winterfell OCP server. And what you should know is that even if this is an open hardware machine, there is no SPI header on this machine. So it has to remove the flash chip from the socket and find a way to remove it in an easy way without having any tools. So we told him just use some Scotch tape and unglue the chip and replace it by using the Scotch tape from the single fingers. So this is just the back idea of how that stuff works. So when Arun came to me and asking me, I want to develop a new way to test the security of system BIOS, and this is what his company is currently doing. So he's working for a startup, and he will he will explain you just later on what he's doing. He asked me for a development platform, and he joined the Linux boot community where Trump sits either. I think 4 months ago. And we sent him our development platform, which is the Winterfell machine that you can see on the right-hand side. And he needed a couple of tools from Flashroms to DDProg programmer, debug custom cards, power supply, serial communications, the nodes, and understanding how that stuff works. So when you came from software, that's a lot of things. And there is another issue when you work for a startup, which is you mostly work from home. And that stuff is not really woman compliant, especially when you are married. And if you are married with a French woman, that's even tougher. And this is the case of Arun, so by the way. So I understand the pain that he faced during summer with that development board. So we started to work together to find some options to enhance the development platform and find a way to automatize the testing. And that's part of the Linux boot CI that I'm going to introduce tomorrow afternoon, so during a longer talk. So I'm just introducing the rough idea that we had around this platform. So the main goal of Arun is to test at scale security of Linux system BIOS images at scale. So it means that is looking and seeking for as many system BIOS images that he could get from end users and trying to identify any malware, virus, or everything which could go wrong with this image. So when you think about it, there is millions of systems in the field. And how can we test that at scale? So we probably cannot test that with this kind of technology. And we started to work together on finding a way to have something which could scale. So we developed from the Winterfell a cloud-based operation. So saying that instead of having the servers within your bedroom or your living room, and replacing the BIOS chips, we should find a way to SSH to platforms and using an API and submit a firmware image, start the machine, and get feedback on the status of basic testings. Like, does the machine has been able to boot? Is it able to boot an operating systems? and can we identify any specific issues from the behavior of the platform. So we don't need anymore to swap the chip. So we are using some Flash emulators and various ways to manage that. We develop a web API, and Arun is now able with his team to get connection directly to servers in data centers and testing firmware as much as he wants. And roughly, we are working with the Linux boot team right now to integrate that stuff with our GitHub account and getting a continuous integration platform, which from every commit, we can check if the firmware generated is able to boot the machine, and if the new features is working properly or not on live hardware. So that's the main goal. So our own tool is called the Armor Analyzers, and as I said, it's collecting image, and you can go on prototypes on these websites, which is armor.ai/scan. So you can upload firmware there and get straightforward feedbacks on your firmware integrity and get analysis. Just to give you the behavior of the Winterfell node that we virtualized to remove the Scotch tape. So we got the SPI Flash emulator. So there is a hardware hack for that. So we had to remove the the chip header from the motherboard, so we removed that with a Dremel. So that's it's not a dangerous hack, but that's a tricky thing to do. You can kill the motherboard if you if you do it the wrong way. But and then we soldered down some pin headers, and we got the emulators, and through the API currently you can stop the emulator, start it, and upload a new firmware image and run the software, and you can power on and off the servers. So just in case your firmware is breaking the node, so which could happen, and roughly it's happening more often than it is working. So that's the thing, and we are currently using that approach for both projects, either Linux boot or Arun project. So that's the other thing. Just to show you, it's not a demo, but okay, my internet connection died. That's a demo. So I was connected to the servers and get access to firmware, but it's dead. So I hope it will work tomorrow afternoon. The thing is, with that technology, you can be everywhere around the world. You get access to data centers, and you can get access to the firmware level of
you can show the
platform.
video.
Yeah, we'll do that a little bit later. So Arun now is going to introduce you his own work on how he can use that technology to enhance his security stack and scale it at some testing hundreds of firmware instead of one by one.
Sure. So yeah, I got involved around 6 months ago with the project. Our aim was to primarily, my background is in endpoint security, so basically malware, anti-malware, so things like Bromium, and that's my world, the world from where I came from. Firmware has started to become an increasingly important idea, to the point where a lot of the endpoint security research is now shifting its attention towards tackling things like the BIOS. So just going back up a few slides. The miscellaneous tool sets that are referenced there is of import. So currently, if you want to do serious analysis, you'll have to kind of find your own way to unpack a said ROM, or you might have to source it from different types of websites and places where sometimes you have encountered manufacturer websites where it's just like an open blob where there's not a proper reference of where the original is coming from or where the comparative firmware can be analyzed either. So it's a bit of a wild west at the moment. Our focus is trying to develop a system which can accept any firmware. So we started out with UEFI ROMs and things like that, but now we have people sending us router firmware, news segment is video firmware, bunches of things like that. So with Jean-Marie's system, the advantage there is that you can start to instrument dynamic analysis as well, aside from the normal static stuff, which we do. So I am a bit bummed that he was not able to show that off, because that would be really interesting. And one of the core things that we did was to also take a look at what's the advantage of running Linux boot versus, say, a stock AMI that came on the Winterfell. So we used the standard in that, which is chipsec. And today morning I heard that the boot time differences, and it appears that even for testing from a security point of view, Linux boot does a bit better. And this is with no particular enhancements. So these are like comments directly from Tremel and Ron with regards to that effort. So with that, what happens is we started to develop a small system where we could accept a ROM BIOS image and then unpack all of the constituent portable executables. So we have all these manufacturers that we have now had a database on, and I think this is off by probably 30 to 40 in the past 40 hours. And since we come from the anti-malware space, we have set of static rules that can trigger on all these EXEs. So it's been a bit fun because we are seeing a lot of smoke. And it is a bit scary. And this is just using static analyzers. And the real aim is to go to the point where we would be able to work with Jean-Marie's system, where we could start to dynamically instrument EFIs in execution and all. Do you want to speak a bit about that?
Oh, it's up to you. So this is your software. So
Yeah, no. For your part, where using your infrastructure, you could actually see things in execution as well.
yeah, that's the thing. So when we are running on live hardware, you can do whatever you want. So you can instrument the firmware and you can get feedback directly. And we mostly use that infrastructure. That's because at the early stage of the Linux boot project, we faced issues to boot up various Linux distros. So there was some kernel tweaking which were required, and the installer were not working properly on the Linux boot machines. And we decided to integrate a full CI and rebuild Red Hat, CentOS, and all the distro to check if they could be working on Linux boot or not straight out of the box. And when we looked at the combination, we said, okay, that's going to be a nightmare if we try to do it by hand, and we needed to scale. So we are able to emulate any kind of production environment with the current infrastructures.
Yep.
So we got, right now the backend is about 100 servers, so only 20 are usable for the firmware analysis, but 80 of them are usable for stressing the machine which are under testing.
So the implications for us is we have done a bunch of work where we've used normal static techniques, and we started to find some really crazy stuff. So this happened in the past 2 weeks. The last two parts, the first ones we've been studying for a while. So there was a well-documented case of a rootkit on a Lenovo in 2015. And what we have found since then is we've almost identified 4 that happened on top of what they got caught. And so that's a bit concerning. The more funny thing is when you look at even modern systems, like these 2 submissions came from, one was from the US, the other one was from Italy. Both of them are fairly recent systems. One is a Alienware machine that's 2017, it's a high-end system, and a Razer, which is also a kind of a high-end gaming system. I don't own any of these machines. These are people submitting their ROMs for analysis. Both of these machines, we would find this is an actual cert that is in the production firmware of this machine with caps lock, do not trust AMI test PK. I kid you not. See, so I think you get the picture. And so we're not, using any kind of very sophisticated things at this point. Even with that, this is the situation. So it is a bit scary. And going back to those stats, I can only speak things in aggregate because as our customers have stepped up, we have been advised that we can't talk about certain things. So on an aggregate, we have almost gotten near about 200,000 EXCs that are of particular interest. Now, these are not necessarily malicious. They might be even some things which are not following proper security hygiene, or they're just doing something that wasn't part of the spec. And so it's really interesting for us is that this is just static. It's not even dynamic instrumentation at this point. And to see this picture is pretty scary. Then we come to the non-BIOS or UEFI firmware submissions that is particularly entertaining because some of them contain entire Linux distributions, default passwords, buggy web apps, and things like that. We started to have more and more submissions that are not really BIOS or UEFI. And we now have been engaged to start developing a methodology by which we could tackle things like supply chain compromise. We also started to get a lot of video ROMs. None of these things are having particularly high level of scrutiny at this point in time, where it is a bit interesting for myself because my world was restricted to TOPS ring -1 till 6 or 8 months ago. So this is a whole world in many ways that doesn't have any security overview or what you would call oversight. And so we could look at some of the ways by which you could do this today is you have to first take a machine and get it to the point where you can get its firmware. So you'd have to do that differently depending on the machine. So if you want to do an extraction from Windows, it's slightly different to a Mac. There are tools like Flashrom, but all of these have a constraint where, in a way, you're kind of forced to trust an untrusted system where it could already be messed up, right? So at that point, you really would want to have a third party or a trusted system that you built out. So that's, again, one more point where Jean-Marie's efforts could come in handy, where we would have a certain guarantee that we are not locked into like that.
Yeah, that's the thing is, I started to work back in the firmware industry about 18 months ago, and I didn't work within that industry for about 15 years. So my background is a chip designer, and then after I diverged to other tasks. And I was amazed that 15 years later, we were using the same kind of tools to test this software. So nothing changed in 15 years. Why I was looking at Linux and how the software developments change, and everything has changed from CVS to SVN to Git and all that things, and the way we are testing software at scale. And we started with our small engineering team to think that firmware security is a strong issue, especially when we are recertifying servers, because we are getting servers which are 2 to 3 years old without any firmware updates. So EME system BIOS, no longer supported by ODMs. The machine is still up and running and can last for the next couple of years. So two options: either we scrap the motherboard because there is security issues, or we find ways to keep these boards up and running. So that's why we started to work on Linux boot. But this was not fixing one of the major issues. How can we test Linux boots? Even if I'm trusting Linux, we still can insert, I shouldn't say malware, but we can misconfigure the kernel, or we can misconfigure the firmware in a way that it's becoming unsecured. And one of the goals that we had by helping Arun teams is clearly to use the brute force and try to write as many test procedures that we can to try to hack and kill Linux boot on OCP servers and check if everything works. So that's why we try to scale the testing platforms to a number of nodes and getting as many tests written down. So right now, the whole testing platform is open source. So you can contribute to the testing infrastructure. This is within the Linux boot repo. And the tests that we are running are not yet open source. That's not a wish from our side. This is just because we are lacking bandwidth, human resource bandwidth, and we are currently hiring resources, so this should be fixed in Q1 2019. So new engineers are joining the team, and you will see coming up a lot of testing procedures for Linux boot firmware. But I think you should be able to use the same process for other firmware based like UEFI, because UEFI is also supported on OCP nodes. So what we try to introduce is really a different way to think about how testing firmware from features and security perspective, and then apply the same rules that everybody knows within the software development industry. And this is easing the task to hire new engineers to work on these kind of subjects. So because when we started to hire people, they were complaining about the fact that they don't know anything about firmware and they don't want to learn because the tools are so different from what they know that they didn't want to take the time to learn new tools which are really dedicated to a very specific work. So, and that's why we said, okay, we need to open up the platform and it should be as open as we can. And that's the current goal.
So I'm going to swap my machine over so that we can start to see some details. So one of the current things that you can look at is when you want to analyze firmware today, depending on the type of firmware, you have to have the image collection down, which currently has a few ways of going about it. In the modern MacBooks around after 2017 or something, you have a nice little tool called IFI-check, which allows you to dump the ROM, and then you can sort of straight away upload that. For other systems, you can use Flashrom. There's also an option in ChipSec where you can dump the ROM. So once you get that done, you have certain options, which is you can use something like binwalk and other tools like UFI parser and so on and so forth to kind of split that image and then start drilling down into the individual items. What's really interesting for us from the security perspective is currently, I think these static heuristics around firmware analysis is very nascent stage, to the point where we are pretty much, all of the innovation in the field seems to be taking what we know to be working in the anti-malware game and trying to apply it into the firmware space. So you could quickly check for a hash and see if that comes up on one of the antivirus scans and things like that. But if we look at it objectively, it is pretty scary to see that unless you're able to instrument it and see it executing in the actual context and in the actual system, there's not a lot of certainty that what you're seeing is the reality. So that's a pretty scary deal. Second, taking a bunch of heuristics that's worked in the normal anti-malware space and directly deploying it into this thing is kind of misinformed in my humble opinion, because it's going to lead you into a ton of false positives and things like that. So the funny thing for us is, even though we have a sort of a funnel to try and isolate, based on just the corner cases that we've seen in the past few months, just looking at the Lenovo rootkit, all of those things are out of the window, because we have seen in some of the other variants, none of the AVs pick it up. So we're back to kind of square one, where we'd have to kind of manually certify. That's why having the real system and being able to see it execute is vastly important. So it is possible to construct a system using only open source effort. I think just a couple of weeks ago, there was a release by a group that's supported by the German government called FactRE, So you could build your own rig where you can use things like binwalk, write up your own Yara signatures, write up your own ClamAV stuff, and then deploy it on a particular firmware. But in our opinion, we need to have a central source of ground truth, and it's not clear to me whether that is going to be a viable thing just using the open source model, because a lot of the manufacturers have their own what you would call motivations in the space. So in our own case, we are now starting to see that some of our customers have certain, parameters, like we may not disclose some of the things that they have, right? So yes, it is possible to construct everything using open source tooling, but having that central ground truth repository is going to be a challenge in my view. At least I have struggled with it to find something that's out there that gives you an easy way to just go and check. So that's part of the reason why we've started to go down that track. And the other complexity comes along where we have firmware for which there is not a lot of scrutiny at this point in time, like your routers and printer firmware. Like we have another friend group who just found out a bug in the Epson firmware. So how do you make a single source of truth for all these different things? And then how do you reorganize the static techniques that we've had in the normal anti-malware game to sort of work with this new space? So with that, we have things where you could take a look at all those tools, or you could use something like Armor and take a look at, let's take a look at a submission that was done. So the idea is simple. You just go to your firmware, and you just pick it up, and you hit open. Hopefully this is connected to the network. And then you just hit a button. It is saying uploading in my status bar, but I don't think you can see it in that screen there. There you go. So the idea is to have, for any sort of firmware, a simple tool like this where you can choose the file, plop it in, and then it gives you the analysis. So in this case, you can have a bunch of stuff that gets you started off on the right track. And at a glance, we can start looking at the total number of executables found. The executables of interest right now, as I said, is not accurate in my view, because we are just retrofitting a lot of the techniques that we used in the normal AV game. I think a lot more bad stuff will be found once Jean-Marie's infrastructure and our efforts in that area are going to get more mature. And this, I think, is that famous place where you could look at there you go. So that's a cert that literally says, do not trust, and it's also expired. So this is from a production machine that is released this year, and this is the state. This is not an old machine. This is 2018. So this is where we stand at this point in time with all of this. So it is a bit scary. For me, I was frankly gobsmacked, because I didn't think this sort of a thing could be possible coming in from the world above ring -1. We have had router firmware where we were able to give our clients everything from default passwords to exploitable web front ends that they weren't aware of, things like that. So for us, the goal is to not have me sit down with Scotch tape and a huge machine and be forced to do that, because it can't scale. You just can't do that with thousands of. You need to have everything programmatic. That's why I'm excited by the fact that Jean-Marie's team is going to work on an actual API.
And if you want to know more about the API, you have to come to my talk tomorrow afternoon. So
Yes.
I'm just advertising it. So, but the thing is, all of this works is done by that's community driven. So if you want to participate to the API and provide feedbacks and all these things, so everything will stay open source forever. So that's really key to us. And even the platform and the hardware platform that we are deploying is currently open source. So we are still using a couple of proprietary components. We have no choice for some of them, but we are trying to enhance all of this. So this is just the beginning of the story. And I really think what is key is just to bring the firmware software industry into a new century, because last time I was in Taiwan, I was shocked by the way they were testing their firmware. That somebody was entering the EMI menu and just clicking, activating features and rebooting and saying, okay, it works, it doesn't work, and checking a piece of paper. And I said, okay, I think most of the mistakes are purely coming from the human who is running the test all day long. And that's not his or her fault. That's because this is a super boring job. And you can miss some tasks, so that's the thing. And the only one way to test that properly is just to automatize as much as we can. So that's the current goal of the project, and this is what we are doing with Arun.
So even from our point of view, as we go down further this rabbit hole, the idea is when we expend human analysis on a singular firmware, we don't want to keep doing that. We want to only tackle what would be changing or difference, and all of that is not possible unless you have the whole thing end-to-end in one cohesive system. So we are still at the very early days. In our case, we were literally incorporated this year, sort of. So it's running at a very breakneck pace. Our aim is to open source most of it, except for the stuff that we are not allowed to due to external customer demands and things like that. So, and that's always a challenge, because I think one of the things that struck me from the Intel talk today morning is, it is a binary blob at the end of the day that they're giving. So, you have that tension of, Ron likes to joke that it's called the golden rule. They who have the gold make the rules. So we can't sort of say that we're going to open source everything, because some of those people will be very upset with us, and that would be a company-ending exercise from where we stand at this point in time. So there are a lot of good tool vendors, especially like if you want to look at even the disassemblers. We have a special relationship with Binary Ninja, and we want to push that relationship to the point where we could have some of these things of the dynamic analysis happening also over the web. So the idea is to start to go towards this place where we can have a single firmware security analysis platform that's pretty serious and works well, and people don't have to kind of burn down their room trying to set up all the equipment, which I did a couple of months ago. So, and I found great help from Bothering Tremel and Ron and everybody on Slack saying, hey, am I going to, blow this up? And so you don't want that, because you want your engineers to be focused on just getting to the meat of it. And, you could potentially do all of this stuff using ready-made and available techniques, but I think the challenge is, as you continue to go to scale, I would find it hard to believe that many different people with different databases would be better off than trying to at least have one common ground truth place. Like today, for example, in security world, we have VirusTotal, right? If you want to do a quick check on a known or bad hash, why do people go there? It's simply because of the fact that it's a known, ground truth state. So I think something like that will happen in the firmware security space, because otherwise it's all a one-off analysis, right? So there's not a lot of discipline around instrumenting the space. So yeah, so that's sort of where we stand. I'm certainly not the expert. I'm just amazed that with just little effort, we are able to find out so much that is pretty scary. And I didn't even have to go somewhere. These were actual submissions made by people on the site. And there's this guy, one of my prospects. he said, yeah, don't ever tell anyone my name because, I don't want to get trouble into company X, right? So so it's a fun state to be in. But yeah, this is sort of where we are at this point, and we are looking for help.
I think that's probably time for a question if you have some of them. Who want to start? We have one at the back and one at the front, so that would be the back.
Thanks for the talk. It was interesting. Just a couple of things. One comment is, having worked with various BIOS manufacturers, IBM here, I am totally not surprised. Secondly, on power systems these days, we do have CI for the firmware, and the way we do it, and I don't know whether that's applicable on x86 or not, because I don't know how you boot an x86 processor, is we actually provide the system ROM image from the BMC. And it's effectively, the BMC can source it from anywhere and put it in RAM somewhere, and make it look like a ROM. So we can HTTP from the BMC a different file, boot the host, measure the host.
Okay.
We can also explode the file system of the as files on the BMC that virtually reconstitute it like a ROM-FS. Okay. So we can replace individual components and NFS mount them from a server that constantly build new binaries, for example. So I know a lot of systems don't have a BMC, but for those who do, I don't know whether it's possible to do that on x86, but it has been very, very useful to do CI.
Okay, that's doable. Roughly, it is doable on x86, so we can go through the BMC. One of the challenges I see with that is, first of all, I still know some servers who doesn't have any BMC.
Oh, of course.
This could
if you have one, and you control it.
And the second thing, we are just moving the issue to the BMC in the end, because we want to test the global firmware stack on the servers. And then we need to instrument the BMC. So just to be sure. Yeah, so roughly we are currently working with OpenBMC. I'm not a big fan of super fat, complex BMC. I'm sorry to tell you that. So, but I'm more a very basic guy who believes that a server is meant to be turned on, stay on, and reset. So that's it. And if it doesn't work for a couple of seconds, so it has to be reset. And if after 3 resets it doesn't work, so just shut it down, and don't try to know what's happening on the machine. So and to me, OpenBMC or all the BMC firmwares are inserting new security threats. So that's due in some way to these kind of features, because you can upgrade or you can fake some firmware image from the BMC. So if your BMC is hacked. So that's another issue.
We have signatures. We have secure boots.
Yeah, I'm convinced that there is a lot of work which is made on top of that. So
you are right, and the BMCs have been a source of problem. In fact, there is hardware features in most common BMC chips out there that allow you to backdoor the BMC from the host.
But to answer your question, so on OCP system x86, you get some generation who doesn't have a high-end BMC, so they rely on ME chips, so which also sucks because the firmware is totally locked. But some of them are relying on 8-speed BMC, so I bet that this is the same kind of BMC you are using on the IBM system. So we have these kind of features. We try not to using them within the CI. That's because we want to be server agnostic. And we thought that the best way to be server agnostic is just to be plugged on the SPI bus or the flash bus, and that's it.
Thank you.
You've been talking about the firmware submissions that...
Yep.
You've been talking about the firmware submissions that you've been getting and that you're amazed about what your analysis of those submissions has been finding. But is that information actually finding its way back to the manufacturers? And if so, do they actually learn lessons from that?
I don't think so.
Oh, this is a great question. Thank you for asking, because I can get started on my soapbox. Short answer is, well, it depends on who is asking them. So if we or some average person ask them, probably they're just going to ignore you. In fact, a top researcher friend of mine tried to find somebody in Epson that he can speak to about an issue that they have found. he was unsuccessful. This is somebody who's taught at Black Hat for 10 years, so he's a known entity. And he, frankly failed to get anywhere with that. So the quick answer is, what we are doing now is that our customers are scary. So they can possibly cause some change in behavior because they are more scary than two guys with a laptop and a bunch of infrastructure, right? So depends on who is asking. So if you're saying, have you guys seen any instances of behavior modification based on the analysis that we are supplying? We are going to see that happen thanks to our customers, perhaps not due to us, because they have got far more bigger checkbooks and decision-making powers than individual researchers. The other thing that I wanted to highlight,
Let me maybe follow up differently on that. So are you doing any tracking across those reports? Like, for example, are you keeping any track of whether an issue that you found in version 1 is also still present in version 2?
Yes, so we are not just tracking across the same product line, we are also tracking for the similar issues across our ROMs to find out if something's tripping. And the great thing about this field is, as we develop a new heuristic, we're going to rerun it on everything that we have to see if we can find out. So yes, that is, we do want to have that constant checking. That's another place where Jean-Marie's ideas are so useful, because it makes it easier for us to create that pipeline where you could quickly check and sort of, make sure that something is not a repeat. I'm forgetting the QA term for it. I don't know. Yes, regression. So the other thing that was a bit amazing is there are whitelists out there in the space where there was an effort by the chipset guys. They had a whitelist for UFI executables that's not been updated since about a year right now. Right, so I have been bothering them in various ways. So right now, I think the way people think about firmware is another potential barrier, because everyone sort of, I think it's like some kind of a mind trick that these guys have played, where everyone just trusts their hardware. Like they can, it's just funny because, you're generally more skeptical about software, but you can't force people to think the same way about their hardware, because even I was in that camp at least 2 years ago. I think my views changed when I had the sudden bug that was disclosed by Intel, and it started me thinking that, hey, nothing on my current Ring -1 security stack can even check for what's going on here, right? So I think part of it's just this mindset about firmware that is really hard to break. Like I've spoken to guys like Ron who have been doing it for 30 years. He has screamed himself to the wall, and I think someday it might change. And so right now, our best answer is we are working with some customers who are pretty powerful, so maybe they can drive a faster response from some of the manufacturers. The other thing is that I think maybe some of the firmware people are playing with an extremely tight margin. They don't have resources to invest into those kinds of things. I mean, their margin is already under high pressure, so maybe there's a good reason for that. It always goes back to, who's making the gold or who's giving the gold, right? So, yeah, but hopefully it will change. Hopefully it will start to get more, I don't know, safer. I think, oh yes.
So I see that you also extract information about the TLS certificates. Do you perform some security checks on the TLS certificates?
You mean to say for stuff like expiry or?
Yeah, also if the modulus is really prime and not just some pseudo prime, something like that?
Yeah, that's sort of the next bits on our roadmap, where we want to do not just that, but also check out which parts are using which certificates for their attestation and so forth. So yeah, we've certainly going to look into that. Our aim is to be able to just analyze pretty much anything that our customers would want us to go hunt. So that's sort of the track.
Okay.
I think we have. Why is that showing red? Is that something that I should be?
That's because we are running out of time.
Oh,
so
yes.
It's not going to explode, don't worry.
So, very quick one. So we mentioned Ben talking about power. What is the status of your platform or architectural coverage?
You can
I
go
think
first.
this is your platform, not mine.
When you say platform, as in
I mean, obviously x86 is
Right.
pretty much the main core. Like, are you also looking into, I don't know, ARM, MIPS, other things?
our aim is to be agnostic, so we are accepting submissions from any sort of chipsets and firmware manufacturers. So the idea is to be one source where you can submit, but our focus right now.
Tools need to be different, right?
Yeah, it will be different. So that's the whole beauty about this is when you're doing it over as a service, you get to make your own decision tree as to how something will be handled. So we are going to have a bit of freedom once we do the initial fast analysis as to how do we go about doing that. Some of the stuff we are not able to handle because we haven't written anything for it just right now. But the aim is to be able to ingest anything and come up with a report on it that says, this is what's funny about it, this is what's strange about it. We started with what we know or what we could learn fast to know, but over time, I think the game is to map out to ARM, to any of the chip manufacturers, and go from there. So we already have people submitting things like video ROMs and stuff like that. So that's the beautiful thing about a web service is that, if somebody uploads something, then you get to decide how to bracket it and do that. And I would again call, there's an open source effort right now called FactRE that was sponsored by the German government. And you can also have this kind of a personal testing setup where you could spin up a firmware analysis system, but I don't think they have all the different tool sets that somebody more commercial would be able to leverage, because some of the feeds, like Jean-Marie said, aren't open source. They're not free. So.
Right. We have
you.
had it here now. Thanks so much again, Arun and
you.
Jean-Marie.